this video, we are going to learn about the 5 types of flange facings that are used in almost every engineering project and in depth. We learn about the standard which is used for RTJ type of gaskets. We will learn about the roughness requirement for raised face flanges. We'll understand what is AARH actually means. We will try to understand what are the different types of gaskets that are available for high pressure applications. So if you see this flange, this is a raised faced flange. How do you understand that? If you see this blue portion here from the side, you understand that it is raised as compared to the other area of bolting circle. Since it is raised, the name has come raised faced flanges. Now let us try to get in depth about the thickness. If you see here in terms of the thickness, can you tell me what should be the thickness for 150 rating, 300 rating, going up till 1500 rating and more? Will the thickness remain same for all of these pressure ratings? What do you think? The answer is no, they'll not be the same. Let us try to understand what shall be the thickness. So for example, if you take a flange here, for smaller pressure rating, logically the thickness should be less. So that for 150 rating and 300 rating, 1.6 mm is also sufficient. And as a thumb rule, as the rating keeps on increasing for 400, 600 and 1500, it can go up to 6.35 mm. So this is a significant amount of increase in thickness that should be noted. Out of these two configurations, which is an easy flow path? Is it configuration 1 or is it configuration 2? If you see here, it makes a lot of sense to understand that when the fluid has to go through so many curves and curvatures, it is too difficult for it to reach the end, right? This same understanding is used in raised faced flanges. You see here, this portion which we saw was raised is actually also having deliberately put roughness into it, and the unit for this roughness has been AARH, which is called as arithmetic average roughness height. So basically how rough or smooth the surface is. You might have seen for a lot of raised face flanges, you have heard the term called as it should be between 125 to 250 micro inches. So what are these criteria for selection? Let us look into that. If you see here, the construction what we saw was, because it is coming in between the two flange surfaces, you can see these are like the teeth which are biting the gasket in order to keep it intact. So in this case, the higher the roughness, the higher the biting capacity to hold the gasket together. As thumb rules, you could say that for a gasket, this would depend on the type of gasket that you're using. For example, spiral on metal gasket, soft gasket, etc. Now let us take for example soft gasket. So in soft gasket, the roughness is required between 250 to 500 micro inches generally, and for spiral wound gasket it is between 125 to 250 micro inches. And further, can you tell me, is this roughness also required for a metal gasket in RTJ? The answer to it is yes, it is required. If you see ASME 16.5 in clause number 6.5.2 states that the roughness shall be but 1.6 micro mm or 63 micro inches in roughness. Now if you compare to what we had seen previously, 63 AARH is very less compared to what we saw 250 or 500 micro inches. So in that case you understand that there is a logic here. The harder the gasket, the lower is the roughness required. Let me repeat that again. The harder the gasket, the lower the roughness required. So you might have seen for soft gasket it goes between 250 to 500 AARH. Then for spiral wound metal gasket it goes between 125 to 250, and here for RTJ it is just 63 AARH. That when you say about raised face flanges, the next flange which comes into picture is flat face flange. So we started with raised face because flat face is easier to understand now. In flat face there is no amount of raised or basically an elevation, so this is only used for low pressure and temperature applications. Can we use these two flanges and mate together? Can we use two different flanges and mate together? The answer is it is extremely not a recommended practice to have at one side flat face and the other side raised face. Both of them are preferred to be either raised face or flat face depending on the application. In an RTJ, a metal gasket is used. So example, let's take this as metal gasket, and that is being put in between the two flanges. So this sandwiched gasket, metal gasket between the two flanges is what is called as an RTJ gasket. Now RTJ has variety of types. And the standard that is used for this metallic gasket is ASME 16.20, which is a standard which is used for also the manufacturing of RTJ gaskets. Now getting to the types, if you see here, the types can be divided into three important things of an RTJ gasket. The first one is R type, the second is RX type, and the third one is the BX type. So first let us look into the R type. R type of gasket is further subdivided into two types, which is the oval type and the octagonal type. First, initially in the industry, oval type was used. Eventually, the industry is moving to octagonal type as a general rule. And if you see here, compared to both of them, can you tell me which one has the higher pressure retaining capacity? The answer is, in terms of both of these gaskets, octagonal has an advantage, so it has a higher pressure retaining capacity compared to an oval flange. But as per your application and as per the already existing flanges, you might have to select the type of gasket for an RTJ configuration. We learned about the R type of flange, right? Now we have to learn about the RX type and the BX type. So if the R type is not able to contain the pressure, then for even higher pressure you have RX type, and then if that is also not sufficient, then you have the BX type. Let us first look into the RX type. This is how the construction generally looks like. If you see here, this can retain pressures up till 700 bar, and the RX type is also inherently interchangeable with the R type of design. BX type is used for extremely high pressure applications. You could say the thumb rule up till 1500 bar, which is extremely high amount of pressure. However, there is one question that is asked. That is, in the BX type, can it be interchanged with the other type of gaskets? What do you think is the answer? The answer to it is that this is not compatible with any other type. This is basically how a tongue and groove looks like, and if you see here, this is different from an RTJ design. If you see an RTJ design here, the gasket is basically a metal gasket and both the sides you have a depression. But compared to a tongue and groove design, if you see, the tongue is basically attached to the flange and the opposite side is a groove that would accommodate the tongue. So this is a different configuration as compared to RTJ, and care must be taken especially when there is an interface between two disciplines, that both disciplines should not buy both of them being the tongue or both of them being the groove. It has to be a combination of both of them. So for tongue and groove and small male and female that we're going to see now, the gasket roughness required is not going to exceed more than 125 micro inches in roughness. So this is lower as compared to for soft gasket, but it is higher as compared to an RTJ flange. Let's look at male and female design. Now the male and female design is similar to a tongue and groove design, but however there are some subtle differences. If you see here in a male female design, the male part is protruded, and that is a very big design as compared to tongue and groove. If you see here, the tongue has a very small portion that is protruding out and the groove which accommodates it. So this depends on the type of application that you are working. I use an image story which I learned from deep work to remember concepts. If you like it, it might seem a bit cheesy. You can stop the video here. If not, maybe this summary might help you to remember the 5 flange types. So getting to it, imagine there's a here an engineer who's on a flat face design, and he goes to a raised face mountain which reminds us of the raised face flange. He finds a ring there which reminds us of the ring temp joint, and he uses a tongue to remove it from the groove, and which reminds us of the tongue and groove type of design, and he gives the ring to a female, and thus the male and female have a happy married life ahead. So hope you remember all these 5 types, which is flat face, raised face, tongue and groove, ring type joint, and male and female. Thank you so much for watching the video. If you're interested to learn control valves in depth, then there is a free ebook available which covers amazing parameters like material selection, valve sizing, valve design, and valve standards. The link is given in the description below. Please subscribe if you have liked the video.